take a closer look at these fatty acids, right? Again, we have just some kind of carboxylic acid, and this R group is some kind of long linear hydrocarbon. Right, of course, I say linear here and as I mean that there's no branching, right? The carbons are still going to zigzag, and they're all single. They're usually single bonds, so they're free to rotate, so they might not, appear linear at any one point. The properties of these fatty acids depend on this kind of long linear chain. There's a lot of logical conclusions here. The longer the chain, the higher the melting point. Right, and that's just due to more dispersion forces or London dispersion forces. Think back from Gen Chem and our review of intermolecular forces. And then other than that, there's two main types of fatty acids, really three, but we'll stick with two for now. We'll introduce the third one later. The first is saturated, and then the second is unsaturated. So think about our chapter on alkenes and what saturated means. Saturated means that we have no pi bonds and that we are saturated with as many hydrogens as there could possibly be. Unsaturated, there are pi bonds. So somewhere in this chain, you have some type of pi bond. And generally, when we're talking about the unsaturated fats, we're talking about cis pi bonds. We'll talk about trans pi bonds later when we talk about trans fats. So when I say unsaturated fats, we're most of the time talking about cis pi bonds. Remember that pi bonds offer no rotation. And overall, this results in a lower melting point. And so the reason that it does this is this kind of little kink in them keeps them from packing as efficiently, and so they stay liquid at higher temperatures. So the kink keeps them from packing efficiently. And so what that means in these saturated fats is that they're more likely to be solid at room temperatures. Right, so for example, right, unsaturated fats are more likely to be solid at room temperature. They're more like your kind of animal fats that you think of, like the fat on a steak or like a butter, something like that. These unsaturated fats are more likely to be liquid at temperatures. They're more kind of your oils, vegetable oil, avocado oil, olive oil, that kind of thing. So we'll call these kind of fat, and then these kind of oils. Although the term fat is just used in so many different ways that it's kind of lost all its meanings. In general, the argument is made that unsaturated fats are healthier because they are less likely to be solids, right? And solid in your bloodstream, which would then lead to a heart attack. That's not a fact, though. There's biochemistry is a very complicated thing, and it depends on exactly what kind of fat you're talking about, and most of the time, it's moderation is really the best idea. So I'm not a nutritionist, I'm not a biologist, I'm not saying these are facts, I'm just saying these are how it tends to be thought of.